Welcome, everybody, to the American Space Museum. I'm Marquette. We're so glad you're with us to stay curious. Today with Steve Agid. Steve is an excellent communicator on Kennedy Space Center Visitors Complex, but he was also a space worker that we love here at our museum, and he's going to talk about his days with the Hubble Telescope missions that upgraded this incredible invention by humans. And Steve, how are you?
I'm just great, Mark. How are you doing?
Good. I get a little verklempt thinking about the Hubble because you can't underestimate the superlatives and the adjectives to describe how important this machine was in changing how we not only think about the universe but our own Earth.
Yeah, it's because, again, it was so different. It's the first time we had a very large observatory out in space, which makes things very different from what we can do on the ground. One good cloud and it ruins your observations for the night. That is not the case in Hubble.
No, it's not. And at 9 feet in diameter, a pretty big telescope even for Earth. Of course, now it's eclipsed by the Webb telescope. But Steve, you had a career as an engineer. You worked for contractors, correct?
That's correct.
Which ones you worked for?
Well, started out my career, very first thing I did, I was still in college, and that was I worked at the Kennedy Space Center Visitor Complex.
And you grew up where? Tell us quickly.
I grew up
little bio there.
in New York, in the borough of Queens, little town of Rosedale, which is right by Kennedy Airport.
Okay, a borough of Queens.
Yeah,
all
borough
right.
of Queens,
so you took the D train up to the town and all that stuff?
On occasion.
Uh-huh. All right.
Yeah, absolutely. Yeah.
But then you ended up as a teenager working at Kennedy Space Center?
I was, let's see, it was 1973, so I was 21, and I worked part-time, and that would be during what they used to call the rush periods, which would be the Christmas week, Easter week, and all summer. And I did that for my junior year in college and after my senior year.
Wow.
I did that, and after that...
And here a half a century later,
51
not
years,
to date you, but,
to date
you're kind of living the dream like I am, involved with the Space Center and all things dealing with astronauts and people that love astronauts in space.
And how much I've gotten to see, because my first job after that, my first, as I call it, my first real job, was to work with RCA, and that was with communication satellites. And back then, we were coming up with what was called domestic communication satellites. Before that, you had things like Telstar, and they could broadcast from different countries, and you could have the Olympics on. But what about domestic, using a satellite for just the United States broadcast? Well, that didn't sound like a big thing. After all, we were told, people have, in the big cities, you have 5 TV stations. How many more do you need?
Yes,
it was a big gamble. Our
right.
spacecraft, the early RCA spacecraft, had 24 channels. And, needless to say, things have branched out quite a bit.
Yeah,
so
we just saw another 24 satellites launched
just
last
the other day.
Night.
Yeah.
Last night, waking us up in the middle of the night.
So I was a spacecraft controller and an analyst for RCA for 12 years, and I worked Shuttle for 14 years. I was a mission specialist, which our title was called mission specialist. We were ones that did the astronaut activities on board the spacecraft if the astronauts were not here. If they were here, they would do the work. If they weren't here, we would do the work. Mm-hmm. And I worked on the payload bay on almost nearly 60 different space shuttle missions. Then that was 14 years, and 14 years on the Atlas and Delta programs as an engineer. So I got to work with a lot of military payloads, didn't work with the secret ones, a lot of civilian, human spaceflight, and commercial. So commercial, human, and military, exactly in the wrong order. Most people came to the space program through military, then they worked shuttle, then they worked commercial. I started with commercial, so it's a little bit different career path than a lot of other people.
Well, that's why we like having Steve Agid on the program. This is 4 or 5 times you've been on. Bart Martindale, one of your colleagues out there, and a friend of ours is also a communicator, interviewed you the first time, and then you did a program on the 50th anniversary of Skylab that y'all need to go back and check out on this YouTube channel. And you did an excellent program in December on Apollo 8 orbiting the moon, which you and I, being kindred spirits and nearly the same age, it affected me and as well as you. Just the awe of going out and looking at the moon that night and thinking, wow, we're orbiting that thing.
That's right.
And a great show. We always enjoy Steve. If you're out there at Kennedy Visitors Complex regularly, like me and Marty, shout out to my co-producer here, Marty Winkle. We're out there quite a bit. If you ever hear his voice in the Rocket Garden, go over there and listen to what Steve's laying on everybody over there, the tourists, because you do an excellent job, and you're going to in for a very great program today that will have some technical aspects to it. So get your education on here a little bit. And we chose a beautiful green screen here. Appropriately, 15 years ago, this image would be seen by our last crew to visit Shuttle, STS-125. Steve, what do you notice about that picture that's different?
Well, the big thing, and I was going to bring it up later in the broadcast, but since you brought it up earlier, take a look at those solar arrays. Those solar arrays look a little bit short if you compare them with the earlier ones.
Yeah,
well,
not gold either.
No,
shiny.
that's true, exactly. Well, it's the third set of arrays for Hubble, and that looks odd that these are smaller. You would think you'd want to use more. Well, in this case, more is less. The arrays are about 30%, about 33% smaller, but they generate 20% more power.
Mm-hmm.
So when we left Hubble for the last time on Shuttle Mission 125, one of the things they updated were put these new arrays in. They would wobble less, so we can be able to take really good pictures, supply more power. The other thing good about these arrays were because they're smaller, Hubble doesn't have any rocket thrusters. We can't move it to a higher orbit.
Well, how's it moved?
Well, we can point it, but we can't move it. We can point it in different directions. It moves about the speed of a minute hand on a clock. Okay, so to make a complete 360 takes about an hour. But we do the planning on where we want to move so we can actually move using what they call roll torque coils that interact with the Earth's magnetic field. But the altitude of the spacecraft we're stuck with. So what do? We went to visit Hubble on a lot of the different missions. We would boost it up. On the mission 109, we boosted it up another 4 miles. What knocks Hubble down? Well, it's the solar particles coming off the sun. With a smaller array, you're going to get less of those particles, so Hubble will be able to stay up even longer. Since it was the last time we'd be seeing Hubble, wouldn't be visiting it again, we wanted to make sure its orbit decayed slowly.
Well, 15 years ago is the last time human eyes seen the Hubble. And I know Jared Isaacman, billionaire that has his own private space company called Polaris North or something. He may go up and do a repair mission on it, he's saying.
That'd be great.
It'd be great. Get a little ahead about what you got to share with us today, but also as you're looking at this beautiful background, want to make sure that you don't forget about that thin blue line there and how tenuous that is, and that's all the border that we should be concerned about on Earth.
When William Shatner made his trip on the Blue Origin spacecraft, he looked at the blue line that you're looking at, folks. That's the Earth's atmosphere, very, very, very thin. He says it separates life from death. Anything under that line is living. Anything above is not.
Yeah. William Shatner at age 91 when he went up
90,
there or something?
90, yeah.
He's still affected by that.
Yeah.
2 years later, he said it has changed his life, that he weeps for the Earth as a 90-year-old man. But it's serious. All the astronauts carry that back to us Earthlings that look at what's keeping us alive and what we're doing to try to destroy it. There you are on a show, our December show about Apollo 8 there. Just want to, again, thank Steve for supporting our museum. We think, though you're at the big place, we never want to be that big, but you get what we are, and we have some interesting artifacts here, don't we?
Absolutely. One of the things that I mentioned just to the visitors I saw here today, there's a lot of things you can see, of course, at the Kennedy Space Center Visitor Complex. I love being there. You can get closer to a lot of those things here. We can take you into some of the firing rooms, and it's all blockaded off. Here you can actually get within a foot or two of the equipment. So
we'll let you flip the switches in our Cape Canaveral gallery there. But we appreciate you being here, all that you do. He's an excellent docent. Like I said, you hear his voice. There you are working on STS-109. All right, that's Mike Leinbach. There, let me see, 49. What are you doing there? What are you in the firing room there?
Okay, that was an Intelsat rescue mission.
1992.
1992. That's correct.
And
this is an odd thing because if you look
Bob
at that
Steek
picture,
actually launched it. So,
that picture was taken at launch. Now, if you look to the picture on the left-hand side, you see the Intelsat rescue.
yeah.
Now, what's unusual about that picture, it is very historic. It is the only time we actually had 3 astronauts outside at the same time. When we do EVAs, extravehicular activities, we always have 2 astronauts. Well, we weren't able to capture Intelsat. We needed to have a 3rd person, so we sent a 3rd crew person out there, and that is the only time in history we ever had 3 people out at the same time. So that was a historic
That's
photograph.
Right. That'd be Akers, Hebe, and Thoet.
And Bruce Melnick, my former boss,
yeah,
he was on that mission.
STS-109. He was on the ARM, I believe. Kathy Thornton may have also been on the ARM. Bradenstein and Chilton were the commander pilot. And it was also the first mission to use a parachute to slow it down at the landing there.
Oh, very good.
And Kathy, we love Kathy Thornton. She didn't do an EVA on this one, but she did historically on the first Hubble upgrade and threw those old solar panels away. Never will forget that image of her. And there you are doing your thing out there. Like I said, you hear him talking to a group. There you are talking to a group. I think it was an international group. That's, of course, one of the F1 engines at the Saturn V facility. That's just so awesome. And to go out there, and if you want to have a great time, you ought to listen to Marty give a little lecture around LEM number 9 laying there.
We have LEM 9 has an interesting history to it. It's a real LEM, was qualified to fly into space. Its history is kind of interesting. Why do we have it, and how did it get here? And the reason is when they canceled the last 3 moon missions, Apollo 18, 19, and 20, we had 4 lunar modules left, numbers 9, 10, 11, and 12. The lunar modules were built in groups of 3. So 1, 2, and 3 were a set, 4, 5, and 6, 7, 8, and 9, then 10, 11, and 12. 10, 11, and 12 were called the extended stay lunar modules. They could stay on the moon for 3 days. They were a few hundred pounds heavier, and they had the lunar rover. Well, now that you had 4 lunar landers left, numbers 9, 10, 11, and 12, and since they canceled the other missions, we only had 3 lunar landing missions left, Apollo 15, 16, and 17. You got 3 flights, you got 4 landers. Which one do you leave behind? Well, they decided to leave number 9 behind because 10, 11, and 12 had the rovers. You can drive 20 miles instead of walking a couple of 100 feet. So 9, real lunar module, the same kind that was used on Apollo 13 and 14, stayed on Earth. And lunar modules 10, 11, and 12 were the ones that were flown on 3 flights because they had the rover.
And the rest is history.
The rest is history.
We just Vance Brand just celebrated his 91st birthday last week, and he probably would have been the commander of 19.
Well, Vance Brand and I have the same birthday.
Oh, do you?
Yes, we do. That's May 9th.
Well, happy birthday
Thank
to you
you
then, Vance, and yourself there. We'll catch that next. Stay curious. We'll wish it to you there. I'm looking here on my smart tablet that Dave Stangy's watching us, saying hi to Marty and Steve and myself. Happy Monday to you too, Dave, up in Michigan. Steve Jokums up there at Lake County Spaceport on the shores of Lake Michigan. Greetings to all of us here in the gang. He's there at Fox Lake, Illinois.
Oh, okay.
And Steve's got a business as Lake County Spaceport. He makes decals for space models.
Oh.
Like your shuttle tiles. There's a decal they'll just put on there and make it look real. Gary Gerald and Georgia saying hello. And we had lunch with William Whiting. Great to see you watching today. Tom Celentano says, I recognize Steve's voice from calling some Atlas and Delta launches.
Yeah, that's the part I didn't get into. Yeah, I did 60 flights for Atlas and Delta. I did mostly the plus counts for the Delta program, which is what was happening after launch, and countdowns for Atlas. And I did that from 2004 to 2016. Every once in a while on a tour, somebody will tell me, I sound like the guy that used to do the countdown. And there's a reason for that.
That's good. That's good. Mike Borelli's watching, buddy. Good to see you. He is staying curious today. And under the astronaut files, Tom UCX watching Pennsylvania says, we're off to a good week, Marty, and we sure are. We're efforting a interview on Wednesday, but we do have coming Terry White. We'll be talking about his days with the pit crew in the shuttle garage there at your orbital processing facilities. Terry will be on Thursday, and we'll be getting ramped up for a 6 o'clock launch of the crew for Boeing, Sunny and Sonny and Butch. And you're going to be taking part in that, correct?
Yeah, I'll be out at the Saturn V facility. I was out there last week. That did not take very long. But I'll be out there again this Friday, so folks that have tickets to be out there for the 616 launch for the Starliner, I'll be seeing you out there. If you do say hi, stop by and say hi when I'm out there.
That's right. And, well, good. Some of you are taking the tour there. I know Borelli's doing it, going out there on the bus tour. And I'll ask your question here in a little bit as we get into our program here, as I've done enough of the preliminaries, I think, to set us up. We love talking, Steve, about the shuttles of every month, and you're going to talk about one of the March shuttles, STS-109, which I find is interesting that it's also Columbia's last successful flight. But STS-125 in May launched just 2 days ago with Scooter Altman in controls there as the commander. It was the last time we did a service mission 15 years ago. Now that's what the telescope was supposed to last, 15 years. And here we are in its 34th year. And it's still in parallel now with the Webb. It's still doing fabulous science there. So with that, I'm going to say take it away, Steve Agid, and let us tell us a little bit about the Hubble and your affiliation with it, and particularly STS-109.
Okay, we're going to actually start from the beginning. I was fortunate enough to work on we had the Hubble mission started with the Hubble 31, which is when we actually launched the Hubble Space Telescope. I was involved in that as a backup person. 61, which is when they fixed the mirror. 82, 103, and 109. The only Hubble mission I did not work was 125. By that time, I was working with RCA, with the United Launch Alliance on Atlas and Delta. So I worked all the Hubble missions except for the very last one.
Mm-hmm.
So we're going to start off the program because, as Mark mentioned just a few minutes ago, we're now celebrating Hubble as was launched on the 24th of April of 1990. It's been in space over 34 years, more than a third of a century. So if you're in your mid-30s, you really don't understand what the world was like before Hubble. There's always been a Hubble Space Telescope in your life.
Mm-hmm.
And so I thought that to bring a lot of the viewers up to date, I want to go a little bit into the history of that Hubble program. Now, in 1946, an astronomer named Lyman Spitzer said, we ought to have, because again, we have nothing in space yet. That didn't happen until Sputnik. So this is 11 years before Sputnik. It would be great, he said, if we had a telescope above the atmosphere, because above the atmosphere, stars don't twinkle, and you can observe infrared light and ultraviolet light. That's not visible on Earth. So if we were able to invent a telescope that could go above the Earth's atmosphere, it would have a lot of advantages. So later that year, we launched a very small, we launched a little small program to take an ultraviolet spectrum of the sun. using a V-2 rocket. Again, fresh out of World War II. We launched an orbiting solar observatory in 1962, just a few years after the birth of NASA, using it for ultraviolet and X-rays and
That was a
gamma
big
rays.
deal, too.
That was very big.
The
OSO, yeah.
OSO was
OSO,
a
very
very
big.
big deal.
The National Academy of Sciences recommended we develop a space telescope later that year. Well, Spitzer, the same fellow that made the recommendation, was put to head that committee, and NASA created a program called the Large Space Telescope. Well, James Fletcher donated $5 million of NASA's budget. Can't really buy all that much with $5 million. But later, we got about $36 million for a telescope, and the proposed launch date was going to be 1983. And Hubble would be flown back to Earth every 2.5 years to be serviced. Now, I want you to think about that. That was the original idea. You send up Hubble, every 2.5 years you go to visit it, put it back into the shuttle, bring it down to Earth again, install new equipment, and then launch it again. Well, if you're going to do that, because of possible launch delays and any kind of other issues, there's going to be a lot of time that Hubble's on the ground.
Yeah.
So there's going to be a change in philosophy, but it won't come for a few years. We started building the mirror in 1979, and then we decided we had to give it a better name than the Large Telescope. We decided to name it after Edwin Hubble. Who was Hubble? Hubble changed our whole view of the universe. We thought there was one galaxy, the Milky Way galaxy, and that's us. And the universe is a big place, and that's it. He found out, whoa, the Milky Way is just one of, we found out later, trillions of galaxies. So because he made that great discovery that there are more than one galaxy, it's named after him. Critical decision in 1984. They decided, wait a minute, if we design this Hubble telescope to actually be serviceable on orbit, it could always stay in orbit. We would just send up a shuttle mission, fix it or improve it or change it, go back down again. Don't bring Hubble back down every 2.5 years. That was a critical decision back in 1984. Now, in 1984 and 1985, when that decision was made, the Challenger accident, of course, delayed the launch, but finally in 1990, on April 24th, Hubble was launched. A few weeks later, we found out that there was a problem with the mirror. The mirror was ground a little bit off. Not very much, certainly not noticeable by the human eye, but we had to go fix the telescope, and that occurred on Shuttle Mission 61. So I think we can proceed a little bit ahead.
Yeah, good job.
Okay, let's talk about the spacecraft itself. Would you mind if I...
Yeah, there you go.
Okay. So this is an idea of what the Hubble telescope looks like on orbit. We have our solar arrays, and again, we've changed a little bit, but the outside, you wouldn't be able to tell too much of a difference on the outside. We have two very big antennas. We have an equipment bay that surrounds the telescope. We have that very big mirror, about 9 feet across. Now, how do we move Hubble? It doesn't have rocket thrusters, and how do you move it? Well, the Earth has a magnetic field. Now, many of you, when you were young, you probably made an electromagnet. You take a battery, get a nail, you wrap a wire around the nail, and then you find out, hey, the nail can actually pick up metallic objects. Well, since the Earth has a magnetic field, if you put coils, and there are 4 of these around Hubble, you can turn them on and off and actually twist Hubble without firing any rocket thrusters. It doesn't move very fast. Again, it moves with the speed of a minute hand. So in other words, it would take about an hour to make a full rotation around itself. But there'd be no pollutants, and you can't have any pollutants anywhere near that mirror. So that is the way we actually use Hubble on orbit to actually move it around. So Hubble has communications, it has computers, and it has gyros to keep it stable. So we have big access doors. You could look in the diagram there. It's at the bottom side over to the left. You can actually go inside Hubble. We have batteries because, again, at every orbit we spend some time in darkness. And that is a general idea of what the telescope itself looks like. Now, For those people that are out there in the audience, want to know where everything is located, I included this chart. You can pause the screen and look at all the different compartments on Hubble and see what's located where. All the different abbreviations, all the different systems we have, and how it's displayed inside the vehicle. So this is looking from the top down, all the different compartments that we have different equipment.
May I point out, it's just not the telescope and the science. You have to have a communication systems with the high and low gain antennas. You have to have it pointed with fine guidance sensors. You've got your power units for everything on there. And of course, the solar panels are creating the energy that's being stored in batteries. So very, very, that's cool to give you all the things that are part of it.
So let's take a look at those missions. Again, we first launched it. Want to bring you up till 109. So let's take a look. Number one, we launched Hubble. And that was, again, I mentioned on April 24th of 1990. Now, when we looked at that, again, we found out after a few weeks that we had a problem with the mirror. So we cannot fix the mirror. It's way too big. You can't replace it. So what do? So even though people say we fixed the mirror, you technically didn't fix the mirror. What we did is we gave Hubble contact lenses.
Because it was essentially nearsighted,
right.
To be explained. Just a little bit fuzzy, and it blew their minds that they were that far off, because they were. But so, like you're saying, you put a pair of glasses on it, so to speak.
Actually, for those of you that have been to the dentist recently, they go inside your mouth with those little mirrors. They're about the size of a quarter.
Yeah.
There's 9 of these. And the device
was a mirror that they looked at your mouth inside.
Right,
yeah.
about that size. There's 9 of these in a device called COSTAR, the Corrective Optics Space Telescope Axial Replacement. They put this in the telescope on Mission 61. And what it did, it took that light, because we knew why we had a problem after we found the problem. And what it did, it reversed the bending. So after the telescope got the light, it sent it to one of these 9 mirrors for the different experiments, and the mirror bent it in the other direction. So by the time it got to the experiment, everything was good. It's like the contact lenses in your eyes. You don't technically fix the eye, you fix the lens so your eye sees what it needs to see. The same thing with Hubble. So we gave Hubble 9 contact lenses. So we found other problems as well. A lot of these things you can't notice until you're in space. One of the things we didn't notice was, ahead of time, didn't realize how serious it was, is every 45 minutes you go from sunlight to shadow. Half the time you're on the sunlit side of the Earth, the other half you're in the darkness. So you go see a sunrise and a sunset. Well, the mirror is fine, but the outside of the telescope, those solar panels, are getting a few 100-degree change instantly. So it's a little bit of a wiggle, a little bit of a wobble. Well, that's not going to be good for your pictures.
From the tension of the metal expanding and
contracting. Well, that's not good.
There's no atmosphere up there.
Exactly. So here on Earth, we generally, it's a very gentle transition between sunrise and sunset. But in space, it's pretty instant. Mm-hmm. Well, what are we going to do? Well, we're going to put new solar panels on Hubble that won't have much wiggling to them. So that was one of the things we had. So that's solar panel number 2, or the second set. And that was on that first mission as well. A lot of other equipment we put in as well. And again, because Hubble was designed to be fixed on orbit, this was great. We then had, in a few years later, in 1997, servicing mission number 2, added some new advanced equipment. And again, one of the great things about Hubble is how fast computer technology progresses. Hubble, like you said, was supposed to last 15 years. Not only is it already twice that, it's been 15 years since we've last seen it.
Yeah, exactly.
Okay? So we know that new and better experiments, new and better computers, all these new things are going to come out in the weeks and months and years ahead. Make sure that whatever it is will fit into Hubble, take out the old thing, put in a new thing, and you have essentially a new telescope. So that was servicing mission number 2. Mission 3 is a little bit more unusual. They had all these great ideas of what we were going to do on servicing mission 3. But if you look on the little chart there, it says 3A, and the next one after that is 3B. Now, 3B is Shuttle Mission 109, the subject of today's talk. Why is it a 3A and a 3B? Why don't you just have number 3 and then number 4? Well, originally, there was only a 3 and a 4. Why is it 3A and B? Well, here's what happened. Hubble's gyros, the things that keep Hubble stationary, pointing where we want it to point, were starting to fail. We have 6. You need 3. They lost a 4th one. Well, now Hubble is just not that good anymore. So it goes into a safe mode. So all of a sudden they decided, we're not going to get the information we need from Hubble. We have to fix that. We need to fix that now. So in order to do that, they pushed all that gyro work into the first of these missions. So servicing mission 3A, that was the 103 flight, replaced those gyros. So Hubble had its pointing ability back again. What about all the other stuff you were planning on doing? Well, we'll do some of it. We'll push the rest of it that we were planning to do to another mission. And that mission became 109. So again, because they had
3B.
to very, right, 3B. They had to replace all of those gyros very, very quickly. They pushed that all into the 3A mission. So we'd have Hubble being active again. And then the work that was originally set, that could not be done now because you're replacing the gyros. We made that mission 3B. Again, that was all supposed to be 3A, but since we had the gyro problems, we pushed them all off to 3B. And that's how we got Shuttle Mission 109, to finish out what was originally planned for the 103 mission. What you see on the table there is just a little bit of an example of what was done to the telescope on each of the missions. So the folks at home, feel free to pause the screen and you get a little bit of an idea of what was done, a little summary of each mission. But now we're going to concentrate more on the 109 mission, which is where we are.
Let me say a couple. Have Marty. We've got a couple comments there. Marty, you want to? I'll get to Steve Jokums there, but Amy Collins has got a nice comment, interesting comment there, Marty.
Yeah.
Why don't you share her comment with us?
I put my glasses on. Wait a minute.
Oh, okay.
Yeah, she says, I wonder what the secret is to building a satellite to last multiples of the planned lifetime. We should make appliances this way.
That's a great idea. Yeah.
Good one, Amy.
Well-
This way, everything this way.
Yeah, we should make everything that way, Amy. But
Well, one of the things, again, it depends on what your limiting factor is. I know on the communications satellites I used to work with, the limiting factor there was fuel. Once you burn the fuel, you don't have the fuel anymore.
mm-hmm.
And sooner or later, you run out of fuel. You run out of fuel, that's it. Now, our deep space probes, like the Voyager spacecraft, they were launched in the 70s. That's nearly 50 years ago.
Yeah,
And they are still working.
15 billion miles from Earth.
Exactly. Way beyond our solar system. And they have nuclear power supplies, which are very reliable. And they degrade at a certain rate. And so you can have very, very, very long-term services. Again, getting your electronics, having a lot of redundancy. But again, things like redundancy always add cost. And if you want those appliances to last longer, you probably could do it, but it might drive up the cost of your toaster.
Hey, good answer there. Thank you, Amy, for that comment there. All right. Proceed with your 109. You got your instruments here.
Okay, so let's take a look. If we can go to full screen on that. So what are we getting on Hubble on 109? We're going to replace a lot of
22 years
instruments.
ago, just wanted to
Again,
interject.
yeah,
22 years
This
ago.
is 22 years ago. And again, this is in 2002, which is 12 years after Hubble was launched.
Which I wanted to interject, Steve, that's a long time in electronic world. And think about how the Windows 98 to the Windows 2000 and so
Exactly.
forth like that. So Hubble is now trying to catch up with the technology that didn't exist when it was launched.
Exactly,
correct?
exactly. For example, one of the things you find very, very difficult to believe, 2007, okay? Take a look at that. That Advanced Camera for Surveys, STS-109, launched in 2002. The iPhone you're walking around with came out in 2007. No one heard of an iPhone when these changes were made.
And the optics are better than what they may have put up there.
So what are we doing here? Well, we replaced a couple of new instruments on board. an advanced camera for surveys. It's a third generation camera we call a survey camera that can look at a lot of different things. The Cosmic Origin spectrograph was put up. It works with ultraviolet light. It's 10 times more sensitive and is 70 times more sensitive for faint objects. So again, an incredible improvement on the old systems. Now, the what was called the STS was out of service for 5 years. It would end up being replaced by the STS-125 flight. So again, these are instruments that will be repaired, the ones that are currently in use right now. The visible and ultraviolet light, 35 times sensitive. Infrared, 20 times better than before.
Than 12
replacement.
years earlier.
Exactly. Precise stellar measurements, brightness changes. So there's so many different things that we've been able to incorporate over these years. And again, these are the instruments that are working on Hubble right now, following the last mission, which was the 125 mission. So we can move on.
Yeah, great.
Now, these are the ones that were put on the 109 mission. So you can take a look on the left-hand side in blue. That advanced camera for surveys was incorporated in the 109 mission. Again, very large areas of space being able to be seen at the same time. Wouldn't focus on one thing, but a whole general area. Quasars and stars in ultraviolet light. That was in the Cosmic Origin spectrometer. The axial placement co-star was removed. That was one that helped with the mirror. We put in another adjustment to take care of that. The faint object camera was going to be replaced. We put another thing in to replace it. So the things in red are all the things we did on this mission to supersede the other equipment. As you said, technology changes in this 12 years. We have new equipment to replace and take the part of the equipment we were getting rid of. So if you take a look at this, again, with PIC 3, the wide field planetary camera, the one that we have now is 35 times as powerful, and it generates 1 million pixels. Pixels are small pieces of photograph. So incredible change from when we originally launched Hubble. And we can come.
Yes.
Okay, so what do we do before launch? That's one of the questions I get all the time. People know that somehow the telescope gets here and the equipment gets here, and somehow it's loaded in the shuttle and it goes. Well, there's a little bit more to it than that. So when it gets here, the first thing they do things like health checks. You know, that makes when the Hubble telescope got here, it made the long land trip from the Goddard Space Flight Center in Maryland. We have to check everything out on Hubble. On this servicing mission, all that new equipment has to be taken here. We want to make sure it all works. Then in red are the parts of the program that I was involved in. So once that offline processing, in other words, Hubble's people taking care of Hubble, we bring it to what's called the vertical processing facility. That facility mimics what the space shuttle looks like electrically and mechanically. It doesn't look like the space shuttle, but it behaves like it. We put it in there. We have an aft flight deck. We do everything there that we would do in the shuttle. And if things fail, we fix it right then. The idea being, if it fixed here, when it goes to the real orbiter, it should work. And that's the way it generally does. So we do a check out there. Where you see site test, it's called Cargo Integration Test Equipment. That is the facility that looks just like the shuttle electrically and mechanically. Then we take the payload to the pad, load it in the real shuttle orbiter, and we repeat the same test. You see IVT, interface verification test, and ETE, end-to-end. Interface verification, right there, the red in the middle. Interface verification, we test every single connection we made. Is everything connected? Is everything working? And ETE, end-to-end. That's a very critical, which is a communication test. We know when this shuttle gets in orbit, it's going to have to talk to the Goddard Space Flight Center. It's going to have to talk to Johnson, Kennedy. We try to make believe it's on orbit. Will it be able to communicate directly to those centers when it's really just sitting on the launch pad? And we do the same type of a test when we're in that test facility called the VPF. So you'll see a picture of me later that was taken during that test. That was in February of 2002. So now that we know the vehicle is connected correctly, we know it communicates with all the stations, everything about it works. We do an inspection, and we do what you see there, which says closeouts. We take one final look at the spacecraft and then close the payload bay doors. Now, out of everything I ever do out there, that's one of the most poignant moments when you're there and they're getting ready to close the doors and you sign off the paperwork saying, okay, you agree, it's ready to close the doors. You realize the next people to see this are the people in space on orbit when they take it out. So you're, for the missions like the Galileo mission or the Magellan mission that went to Venus, Galileo that went to Jupiter, you know, you're one of the last people on Earth to ever see this spacecraft. The only other people that'll see it after you are going to be the astronauts when it's in space. So that's it. When they close the doors, that's it. It's going.
That's, like you said, a poignant moment there. Everybody feel that way, or just a few?
I would
mean,
think so.
you know, I think you're romantic at heart, like me, and so forth, like that. So that's good that you take a moment to smell the roses.
I think, as far as I know, like I said, you can't go inside people's heads, but I don't know how you can process these things, work with them for months on end. Now, again, you have laboratory missions. They send the laboratory up and the laboratory comes back down again. That's a little bit different. You're sending something to the planet Jupiter.
Yeah,
you know,
right.
It's like, that's it. It's going and it's not
Goodbye.
coming back.
No
And
one's going to see you again.
And that's it. No one's going to ever see this again. And if you want to know whether or not that affects you, then I would tend to think recently when we sent out the orbiters for display, we had, you know, Discovery going to the Smithsonian. We had Endeavour going to Los Angeles Science Center. When those were gone and the 747 picked them up here and made those final routes, I remember looking up and telling the fellow next to me, you know, that's the last time you're ever going to be able to look up and say, look at that, there's a shuttle in the sky. Because Atlantis, when it landed here, it wasn't flying. It was going to be rolled over to its display area.
Great memories there. Steve was telling, we're talking with Steve Agid here. Always enjoy his programs on our Stay Curious, as does Steve Jokums. He says, Mr. Agid always does an excellent show. Kudos. And you were telling me that you are writing some of your memoirs down in some of these.
Yeah.
As everybody that has interesting careers usually says, I'm going to write a book about it. But you're actually got your teeth cut in 400 pages, you said already?
402 as of 2 days ago. And it'll go through everything, but it's not a biography. It's a memoir of all the things I've done.
Like you just
space,
explained.
yeah, all the way from 4th grade. The first memory that I have is of Sputnik, believe it or not. And all the way through college and the space courses. When I was in college, again, I hate to say it, but we're about the same age, and almost down to the day.
Right.
I was at college here when we were doing the moon landings.
Right.
And can you imagine a better place to be in college than here at Florida Tech, going up to see the launches? And again, with Apollo 17, you know, looking
I
up,
can.
you know,
Standing beside Marty out there as he's
Exactly.
watching his Grumman lunar modules leave the Earth up there. Yeah, Marty.
And, you know, seeing that Apollo 17 go, knowing that's the last moon flight for a long time. And then after Skylab, there's never going to be another Saturn V. So, yes, I will, you know, say I'm guilty of being a little bit on the romantic side when it comes to
Well,
that.
that's great. You were capturing these memories, and we want you to share them here on Stay Curious. Marty, did you have any more comments or questions over there? Do you have a question?
Yeah.
I see Cliff Watson down in Pomona, Australia, said good morning to us. He's having brekkie down there as
There you go.
it's Tuesday where Cliff Watson's at. Cliff was here for the eclipse. He sat there on a couple of shows.
Very
Was
good.
here in the States for about 3 months. So glad that he's having a good time down under as they're starting to get into their winter down there south in there. Well, like I said, we're enjoying Steve Agid here. He's a communicator out to Space Center now. And if you hear his voice, go over there and hear what he's got to share with all the tourists out there.
Love meeting the folks.
Good. The payload bay.
Right, what did it look like? Okay, this is the inside of the bay, and there's a color picture of it later. All the equipment that we took up, if you can see it, the rigid array carrier, that's where we stored those solar arrays. So there's different pieces of equipment, each in different places. In Bay 4, which is in the bottom left of your screen, that's where we carried the arrays. The advanced camera for surveys, the cryo cooler, which was the instrument that was supposed to be at very, very low temperatures, very similar to James Webb. They originally loaded a solid block of nitrogen. It was supposed to last for a long time. It was supposed to last until 1999, but it failed in 1997. Well, you need very cold temperatures. Now you weren't going to get it. So we had to come up with new equipment. And they came up with a new cryo cooler that they were going to send up. So this one experiment would be able to work again. Then we had the very, very back, the mule carrier had the new NICMOS, which is the near-infrared and spectrometer in the back. So we have a color picture of that on the next slide of what it kind of looks like. So that's what the orbiter's bay looked like. So the lower left, you see the forward end of the orbiter. You can see the airlock just to the right of where it says forward, how the astronauts got out.
The mule, that's where it was captured?
Right. Yeah, that's the multi-use lightweight equipment.
Multi-use lightweight equipment,
right.
Marty. Mule, there's a good
There you go. And we have that near-infrared multi-object spectrometer that is going to be in getting its replacement for that new fuel, which is going to be a different fuel than before, and that one is going to replace that solid block of nitrogen.
Mm-hmm.
That was a neon gas. The as run, when we close out a document, we have to have all the buys on it. Everybody did their work, etc., and so on. So this one was for one of the procedures. This is a copy of the as run, which means I signed it off that we're ready to go to the next phase of the test. So just an idea of what that looks like.
I've not seen one of those documents there.
Okay.
Got your little rubber stamps all over the thing there, I see there.
Right. So the reviews are done, and we're indeed ready to proceed with the next phase of the operations. This is the photograph that I was telling you about. It's an unusual photograph. We have very, very rarely get a picture of us actually at work. This was at STS-109. And it was on February 22nd of 2002. We were doing that end-to-end test, which is that communication test between us and between the orbiter and the Johnson Space Center, the Goddard Space Flight Center. We had to make sure that Goddard could talk to Hubble when it was on orbit, going through the shuttle. And here I am. It's in the cockpit. I'm in the commander's seat right now, the left seat. We're facing upward, so I'm on my back looking up. In back of my head would be the top of the orbiter itself, the overhead panels. Renee Ahrens, who simulated what the pilots would do. We have two people in there usually, the payload person, which is a mission specialist one, which would be my position, and then CDR, the commander, and that would be a USA person, United Space Alliance person, and he would do the things that the pilot or the commander of the mission would do. So the two of us together would do the whole flight crew and their operations. So the overhead panels are just behind my head there.
And who's there swatting you with to tell you don't touch that?
Oh, no.
The idea don't touch that.
No, my job is to touch that. That is the job.
Okay, but there's certain areas. I mean, bit freaked out that you don't
touch what's not yours. No, you touch your own stuff. You have enough trouble with your own stuff.
Okay.
Yeah, no, you would never dream of touching somebody else's stuff.
That's cool. That's a great little picture there. You go. There.
But the way that happened
commander's seat. That's
Columbia,
huh?
That is Columbia, and that was the. We had some people visiting from the Johnson Space Center, and they poked themselves in the hatch, and they said, do you mind if we take your picture? And I said, are you kidding? I'd love that. I mean, I worked out here all these years. I don't have a picture of me inside. So this was a great opportunity for me to get a picture of me actually at work.
Yeah, it's a different culture now. Everybody have a camera on their phone.
Right, exactly.
So the crew here.
Okay.
And, let's look at the illustrious crew here.
Okay, that's our crew today. For this mission, Mike Massimino, it's his first flight. He wrote a first book. He wrote a second book later. First one called Spaceman. I definitely would recommend that. He grew up just a few miles from where I lived, and it just goes through all the trials and tribulations to become an astronaut, get assigned to the Hubble flight. which is just terrific. And he was picked to do the 125 as well. On 125, the last mission, they wanted to make sure everybody was a veteran with Hubble. This is our last time. We want to have people that were very familiar with it.
He also is on the Big Bang Theory.
That's right.
And very popular segments of him being on the space station when Wolowitz went
That's
up
right.
there.
Yep.
And he and Garrett Reisman do a podcast called Two Funny Astronauts.
And I've listened to it.
Yeah,
Yes,
I've listened to it a few
absolutely. They have a
times.
lot of fun.
It's not like us. We know actually what we're going to talk about before we turn the
No,
mic
yeah,
on.
with them, it's whatever
I think
it is.
they just start talking.
And they talk about a lot of their fun stories.
They do. And he's a New Yorker through and through.
Yep.
I believe he teaches at New York.
That's correct.
They're one of the universities in Manhattan. So
Scott
proceed
Altman,
there with,
Scott Altman. This is his third flight.
in the middle
He made
there.
a flight there. Nancy Curie. Now the way I had this arranged here, that's the official crew photos. You can see under Mike Massimino on the left-hand side, he was. We had 5 spacewalks on that mission. So they divided up to one crew would do number 1, number 3, 5. The second set would do numbers 2 and 4. Mike was doing 2 and 4. Rick Linehan was doing numbers 1, 3, and 5. Carrie was the pilot. Scott Altman was the commander. Nancy Carey did the remote manipulator system, or the Canadian arm operations. Then Jim Newman did EVAs 2 and 4 with Mike.
Nicknamed
John
Pluto.
Brunson,
You see Newman all the time.
Oh, yeah.
He's an astronaut.
I'm sure a lot.
He was just here last week. Wasn't
Yeah.
he?
And John Grunsfeld did the EVAs 1, 3, and 5.
He's one I'd love to meet, Grunsfeld.
All right.
And don't underestimate the arm operator.
No.
Very key, and it's not as easy as it looks, right?
One of the key things about the arm, people say, you just move the arm. How hard is it? The arm would break with 25 pounds of force. And you say, wait a minute, Hubble weighs way more than that. So you just can't pick Hubble up and just fling it. It's very, very gentle. You can't put that much force on it, or the arm itself would break. So you have to be very, very patient.
And there's in fact, I'm reading in Tom Jones's book, Marty, that we get autographed the Hubble stories. There's several arm operators in there that talk about some close calls.
Oh, yeah.
With almost hitting the side of the shuttle, or almost hitting the door, the payload doors or something. And they're a little bit different than the simulations, kind of threw them off.
One of the parts about that is, you're at the end of this, 50-foot long arm, and you say, well, I need you to move a little bit to the left. You're looking at the arm this way. The astronaut's up there. What's his left? My left?
Stage left, or
right. What are you trying to say here? So again, but they practice these things in the water tank, at the Johnson Space Center Neutral Buoyancy Lab. But when you're on orbit, it's a little bit different. So again, a lot of patience is required.
Mm-hmm. Yeah, okay. Marty.
Talking about the arm being difficult, and you say they can see the arm. In some cases, they don't see the arm.
Yeah.
They're using TV monitors, which makes it even more difficult, obviously.
Yeah.
Those TV monitors are by the back windows, just a little off to the side by the left-hand panels at the back, and there's 2 monitors right there. And again, when you go those close-up operations where you're trying to connect, get the snare over the grapple fixture so you can grab onto Hubble, you can't see that from 50 feet away. You depend on those monitors. We have a camera right there at the end effector. We have a camera on the elbow and a camera at the shoulder where it attaches to the orbiter. So you have different cameras. Switch those around. Make sure you're looking at what you need to see.
Amy Collins mentions that the remote manipulator system arm could not even lift itself on one gravity on Earth.
And you can verify that by going out to the Atlantis facility that we have at the visitor center. You'll see it's suspended, just like the payload bay doors.
Yep. Some of this stuff always amazes me that it looks strong, but it's made for zero gravity.
Exactly.
And you could not walk on the ladder on Earth of the lunar module. It would break.
One of the things when I do the tours of the Saturn V, you tell them that all this was designed for 1/6 gravity, not Earth gravity. But unfortunately, it's going to be on Earth. They said, well, it seems to be standing up very well here on Earth. Take a look underneath. You'll see it's on supports.
Oh.
And the other is take a look at the lunar roving vehicle. You'll see that. It looks like it's on the ground. It's not. If you look underneath, oh, there's a little air in between the ground. Yeah, there's supports under that as well.
Check that out.
Check that out.
That's,
Absolutely.
absolutely. And the Cliff Watson down in Pomona, Australia, saying, imagine how many photos you could have if they had cameras in their phones back then.
Yes. And like I said, I'm happy with about maybe 3 or 4 photos, and I'm thrilled that I had that.
Yeah. Well, we're going to have the launch here, as we've been talking about STS-109, a March 1st mission of 2002, and then just May 11th, 15 years ago.
2009.
Yep, 2009. It was the last launch, STS-125. Both of them commanded by Scooter there, Scott Altman, very popular astronaut, very good guy. He just did a talk for the SANS Space History Club last week. I did not go to it, but I always love encountering an astronaut when they're orbiting the Earth, juxtaposed in time. And but we'll be seeing him at the Astronaut Cocktail Challenge that the Astronaut Scholarship Foundation will put on at Zorella's in a couple weeks. So, but great astronaut crew there. On the far right there, James Newman. His nickname's Pluto. Big surfing guy. He pretended he was hanging 10 on his couple of his spacewalks there. I think Dwayne Carey, that was his first and only flight.
Mm-hmm.
There late in the game. He didn't fly again. So, and Linehan, his third flight there, kind of a under the radar astronaut you don't think too much about there. All right, the launch.
You can see it was a very, very early morning launch. The biggest takeaway I have from that is something very, very unusual. I was not on console that morning. I had a special tour group that they wanted me to take around. But a few minutes before the launch, they told us to look up because Hubble was going to be approaching directly over the pad. And there it was. You could see Hubble, this bright star going across the sky. So it was the only time I saw Hubble right before launch. That was just a wonderful memory.
That is sweet. Catching the morning sunlight. And then here's the servicing mission they did.
Right. So this is the key. The spacewalks we did, what was done on each of the different spacewalks. Now, if you look at the far right at each one, like on the first one, in red, you see plus 31. What do I mean by that? We do the planning. You do the rehearsals over and over and over again. Well, the first spacewalk went about 31 minutes longer than they expected it to take. So I have on here this first spacewalk. What we were supposed to do is we were putting those new arrays on, the ones that were smaller, again, about 30% smaller, but 20% more powerful. So again, the orbit wouldn't degrade as fast, so we'd have Hubble up for a longer amount of time, and we would return these back to Earth. So that was one of the objectives of the first spacewalk. So the first spacewalking crew, we talked about that crew, and that was going to be, again, Rumsfeld and Linehan. Newman and Mike Massimino, they are doing the second one. It is planned for 7 hours, went 7 hours, 16 minutes, so about 16 minutes over. Again, remote manipulatory center system was handled by Curie again. They removed the other array, the port array, and stored it. And they also installed the new reaction wheel and installed some thermal covers. The third EVA went back to the first crew again, and that had a lot of issues. Again, you had a first EVA, which had no problem. A third EVA, we had a problem. What was the problem? Getting the spacesuit ready, and what did we find out? We found out that there is a leak. The port Freon loop on the outside of the spacecraft, that's inside the cargo bay, okay, inside the doors, the Freon loop is degraded, but okay, so they can continue the mission. There was a problem with the airlock door, but Newman was able to fix that, so that was good. And on the third EVA, which is what we're talking about now, all this was earlier on the flight. The other problem we had on the third EVA is when Grunsfeld got his suit ready, found out there was a water leak on the inside of the suit. So what had to happen then is we were going to be taking out the power, what's called a PCU, or the power control unit. Hubble has been on since it was launched. We have to shut Hubble completely off to remove its power unit. It's never been turned off before. So, Goddard Space Flight Center, remember we talked about that end-to-end test, is communicating to shut Hubble down. Well, now we find we have a leak in the suit. We haven't gone outside. We have a leak in the suit. It's going to take 2 hours to get everything set up again. So now Goddard has to power Hubble back up again. Then we fix that. They go out to do the walk. Goddard has to power Hubble back down again so they can replace the power unit. But everything works well. There's 36 connectors on this power unit that have to be mated. And after they were done, came back, they ran a test, everything worked fine, and about 40 minutes after they finished, they found out the power unit is working just fine. That was a big relief to everybody. Finally, EVA number 4. At that point, again, we're going to that second crew again with Mike Massimino and Newman, and they're going to be taking out the faint object camera, which was one of the early experiments, and putting in that advanced camera for surveys. So again, something that was going to increase Hubble's capabilities. And that new cooling system. Remember the other cooling system, the solid nitrogen block, ran out way earlier than expected. Mm-hmm. So they got the new neon gas system in. That worked on the 4th EVA. Finally, the 5th EVA, the last time we ever touched Hubble, was done by that same crew that did the 1st and the 3rd. Uh-huh. They put in new radiators, collected the Canadian, a lot of electrical cabling, ammonia lines, etc., and so on. Then that new cooler. So everything that we're going to ever do to Hubble is now done as far as we know, because 109 is supposed to be the last Hubble mission. Now, why was that done? The idea is we need to use the space shuttle for making the space station. Hubble has a very big, I like to call it a fan base. And they said, we really need, this is 2002, we really should have another mission. Now, after this mission, again, this was the last successful flight of Columbia. Its next flight was Shuttle Mission 107, of course. The spacecraft was destroyed on re-entry. So the thought was we won't have a problem like that anymore because every other mission is going to be going from Earth to the space station. If there's something bad on the shuttle, the crew's going to be at the space station. They'll find out it's bad. They'll stay on the space station until we can get them back. Well, Hubble and the space station are nowhere near the same orbit. The space station's about 250 miles up. Hubble's about 325 to 340. They were pressured, and NASA decided to buckle in and decide, something, we should do another Hubble mission. So that period from 2002 to 2009, there was a 7-year gap. Again, like you were saying before, technology is improving. We're going to get that second mission. So how do you make it safe? We'll have 2 shuttles on the launch pad. So if something does go wrong, we'll have a shuttle that can go up and get the crew. And that was the idea. That was a compromise that was made. And that gave us the 125 mission. So we had one last time to visit Hubble, and that would be in 2009. Again, 15 years ago this week.
And I was remiss in not putting a slide of that historic 2 shuttles on the pad up there. 400 was the safety mission. Yep. We'll talk about that later, maybe tomorrow, and stay curious there.
I think we're going the wrong direction.
No, we are going in the wrong
there
direction.
we go.
Yeah, there we go.
Okay, so let's take a look at the summary. So if we were to look at the summary, so what would we get out of Hubble and the servicing mission 3B or 109? It was released on the orbiter bay. It was the first mission since the International Space Station was occupied that didn't go to the International Space Station. Every mission was dedicated to the space station. This was an exception. So the crew was actually able to talk from the shuttle to the space station. So it was a first crew-to-crew conversation between two craft.
That's interesting.
The first successful mission of the Space Shuttle Columbia, I should say last successful mission of the Shuttle Columbia. The accident was about 11 months later. Now, again, until a decision was made that we should have the Shuttle Mission 125, as we talked about before, because in 2004, the administrator at the time, O'Keefe, saying Hubble servicing is done. It's gone. And then the Save the Hubble campaign. Petitions were sent. 26 astronauts signed the petitions. And Hubble was just a well-loved spacecraft, even today. And this is 15 years later.
Absolutely.
So Hubble, the decision was made in October of 2006. Mike Griffin says we are going to add that mission. And at that point, that's 7 years more of science and technology that we would incorporate into Hubble. And as of this time, the Hubble Telescope has taken 1,600,000 images and has been used for 21,000 scientific papers. So that's a wonderful legacy. And
How
the
many
greatest
doctorate
thing,
degrees?
yeah,
theses
I
out
know
there?
people
Hundreds of
just
doctorate.
locally, just at the Florida Tech, I know some
Yeah.
professors working on it. And again, this is, as of today, Hubble is still working. And more importantly, it's working with James Webb. So you have so much more opportunity to do so many great things out there using Hubble, which again originally came in 1990, originally proposed in the 1940s, and now we are, in the 2020s already. So it's a great opportunity to do these great things.
There's been a hiccup in the last couple of weeks. Have you kept up with that? One of the gyros went down and they've put it in safe mode, but I don't know if it's come out of that yet.
Yeah, it's been 15 years since the last time we visited. We know Hubble's not going to last forever. We're hoping to get as far as 2030. You mentioned earlier that there might be a privately financed Hubble repair mission.
Yep.
So
Jared Isaacman's talked about doing a service mission on it. It's just amazing. And 34 years it's been operating. Our Shuttle Fest 4 next April is going to be focused on the 35th anniversary and bring in Hubble astronauts, hopefully, and talks like this great one that we heard from Steve Agid today. Steve Jokums wanted to know if you knew a JPL Hubble Operations Support Team, a host, gentleman named a guy named Joel. He met a guy named Joel. Does that ring a bell? The Hubble Observation Support Team.
There was a host payload on STS-95. We joked about it, calling it the fake Hubble mission. And STS-95 is probably best known as the John Glenn reflight mission. But they tested some Hubble equipment on that mission. That was a host payload.
Okay.
Okay, so I don't recall the name, but again, host, that's 1995, or STS-95, that's 1998. So you're talking 26 years ago. So you might want to tell him that I'm just not as... I don't recall, and I'm really sorry about that. I apologize.
But appreciate it up there. Could the Hubble... John Borelli, I called him Steve, John Borelli, or Mike Borelli, I called him earlier. John Borelli out there wanted to know, could we get to the Hubble and improve it for another 10 or 15 years?
Okay, if we had something like you're just talking about Isaacman going up there, Hubble was meant to be repaired in space. That was a very key decision, that the idea we wouldn't have a fixed spacecraft. It would be a spacecraft that you'd be able to update. And the way I explain it to people very simply is if you have a very, very old house and you have a plug on the wall, you can plug in an old tape recorder, you can plug in an old phonograph, you could plug in a top-of-the-line computer into the same plug, because the plug is the plug. And Hubble was designed that you can connect to its connectors. whatever you want to put in, just make sure your new connector fits into Hubble's connector. And that's it. We replace the computer systems. We can replace so much of Hubble.
Right there's the Hubble.
And
right
that's
there's
Hubble,
the
yeah.
mirror, the 9-foot mirror at the end here. A long tube, just like a reflecting telescope. The barn door that they open and close to keep debris out of it when it's near the shuttle. And they can do that for meteor storms.
And that's a 125 shot. And the way you can tell that, again, is because look how small those arrays seem. That's that new array that's smaller but more powerful.
Taken 15 years ago. Love for human eyes to see it one more time in our lifetime. Steve, what a great program here. As usual there, you can always expect Steve to bring you some facts and some great timelines of things that are going on as he was in the payload bay for these missions. We'll look and see what is happening in June and have you back then.
Okay.
Is there anything else you wanted to share with our viewers today?
Want to thank everybody for listening and for paying attention to these things. It's a wonderful set of programs they have here. And the fact that you can go back to the earlier days. I mean, some of the people sadly have passed on, but their words are still there. You can still contact them on the website and listen to what they had to say. It's a one-way time machine looking back into the past.
Absolutely.
For people that are no longer with us.
Hubble huggers out there.
Yeah.
We know you're out there. We're going to bring Ed Reziak as part of our Shuttle Fest next year. Ed helped train the astronauts that did the spacewalks up there. So we're already working on a great program 11 months from now to focus on this wonderful time machine that's changed the way we look at our universe. Marty, have you got something to add?
Yeah, Mark, why don't you talk a little bit about the trivia thing? Talk about the patch. Remember what I mentioned to you last week about the patch?
Oh, the patch?
Yeah. 109?
Oh, yeah, the 109 patch. Yes,
be on the
let's
first
go.
page.
Yeah, actually, that's a great way to end it here. Let me put it up there, Marty. I'm doing it there. There we go. This 109 patch. We love our art about the patch there, but Marty showed me something about this patch that I don't know if you know.
Okay.
About 109. Of course, let's end it with that here, Marty. Great way to do it. Let me get to 109. Of course, you got the Hubble Telescope. The patch is flying over North American continent. Inside the the aperture is a portrayal of the spectacular Hubble Deep Field. Okay. Billions of galaxies and stars in the universe. And then it's got the advanced
camera
survey on there. But there is a hidden little, what they call Easter egg there in the art world.
I did not know about an Easter egg on this one. Okay, where is it?
Marty, why don't you let us know in on that?
Okay. Everybody knew, the crew knew for sure that the Hubble has the capability of looking at billions of stars. So if you look at the 109 on top underneath Altman, you see 109, you see the 9, it's a little bit smaller. Then the 1 and the 0, that's 10 to the 9th power, which equals 1 billion.
Very good. I like that.
Isn't that good?
Okay, I just thought it was a little bit off. Okay, it's actually supposed to be an exponent. Very good.
10 to the
Very
9th
good.
Power there for
I like
a billion
it.
there.
Very good.
And Newman told you that at his talk?
Yeah.
Yeah, Newman gives a great talk out there. Have you ever introduced him?
I don't think so.
Yeah.
I saw him last week. He was here, I think, about a week or two ago.
He was. Yeah, last week. His crew was the dog crew, and he was Pluto of the dog crew.
Now you're talking about future programs. I love patch designs. Two of my emblems flew in space.
Oh, really?
So patch designs. I know if you've ever had
Tim Gagnon, of course.
very good. Tim.
Yeah,
Okay, yeah. If you had him on, the Easter eggs or the little hidden things about patches or something.
Yeah, that's what I love. I like this book. And
program on that
and
tells
I know
you about that.
They sell at the gift shop, and we love talking about the patches because it's
good.
artwork and art's important and so forth. Well, Steve mentioned like us on YouTube
Facebook.
and Facebook and so forth. Our social media is going great. Steve and I were looking at the demographics on Facebook with almost 12,000 people we reached a quarter of a million people in the last 30 days.
That's
So,
amazing.
we're happy about that, and we need to monetize that because as a nonprofit, you all know that we need bushel baskets full of $100 bills to keep this place open, and you are responding to that, and thank you very much. Well, we're going to have you get up there and sign our guest board for this year there, but I wanted to give you a Rocket Hobo patch. I don't think I've given you an official
No.
Rocket Hobo patch from Ozzy Osbourne, who passed away last year.
Okay, well, thank you very
And,
much.
well, you're welcome there, my friend. And thank you so much for
Enjoyed
being
it.
willing to come in here. We'll cook up something in June.
Okay.
And because I know that everybody out there enjoys what you have to share. So, Marty, thank you for a great kickoff this week on our Streamlabs job here. And Gary Gerald said, would NASA be open to a private funded mission? I believe who technically would own that from Gary Gerald? That's a good question. Who owns it? Does the Hubble Institute in Baltimore, Maryland own it, or does NASA?
That'd be kind of curious. I know when you look at the Axiom folks, they fly people to the International Space Station. You know, SpaceX works with Axiom to take civilians. And Mark, you can make a flight. All
Yeah,
you need to come up with is a couple $1 million.
60 million.
And they'll fly you up there. How that would be done with Goddard, again, it's never been approached. So
Yeah.
it'd be something to research.
Yeah, that's a good opening. We'll look into that, Gary. Thanks for watching today. Yes, Marty.
Yeah, Mark, I think you missed asking Steve the astronaut files question. They want to know what kind of longevity can we get if we repair it, 10 to 20 years, perhaps.
Well, right now, again, we're talking about some technical problems. Again, it's been 15 years since we last went to Hubble, and the program was only supposed to last 15 years. So it was destined to be finished in 2005 with a launch in 1990. When we got that extra flight in 2009, it's been 15 years since then. If we had the ability, right now they're hoping it goes as far as 2030, which is another 6 years. But as equipment gets older and older, and again, we're not servicing it. So if something goes bad, it could be very simple to fix, but if there's nobody up there to fix it, it's not going to get fixed.
However,
So-
they're going to safe it, and
Yeah,
it's 450 miles up,
Right.
so it's going to take a couple centuries to probably degrade.
Yeah, it'll take
come
a
down
while.
naturally,
With the
but,
smaller arrays, that'll help. But if
I
they
think
get-
it'll be visited sometime in
there
by
was
humans.
a time where they expected to bring it back down to put it
Yeah.
on display. But if we have again private venture, I would think that it would just be a great place if you can come up with a platform to latch on somehow to Hubble, use the bottom end of Hubble, the docking system, and have something docked to it and just make a couple of short repairs. Hopefully, something simple, but there's a lot of training involved in going inside Hubble to do some of this work. But
and what they did with 125 was work they never thought was going to be done. I
Exactly.
remember Massimino training, and he was like 2 hours moving bolts. I mean, nuts, just a quarter of a turn for an hour to get it off. And wow, that's some patience.
Yeah.
Orbiting the Earth in daylight and darkness
darkness
every 45
going back.
minutes. Excuse me.
Yeah, again, the training, the amount of training you do, and then I can't imagine a private crew wanting, being able to do this. And then again, the people that have been doing this, people like Mike and those crews, they're not getting any younger either. So be kind of a tough thing to do the first time you go into space to actually try to repair Hubble. That would be very, very difficult, but it's not impossible. Nothing's impossible.
We've got CB Spock says a really good book on Hubble is Handprints on Hubble by
Kathy Sullivan.
Sullivan.
Excellent book, yes.
And not Thornton. Thornton was a space worker.
Yeah.
Sullivan never visited it.
I think it was it Kathy Thornton?
But I'm
or
not
Sullivan?
going to quibble on
No,
that.
no,
We can look that up.
you might be.
Handprints
might be
on
Thornton.
Hubble. I
Wa-
didn't think
it was
Kathy Thornton had written a book, but
or was it Sullivan?
she'll be out to Space Center here
It is,
end of
yeah.
July. But no, thank you all. Amy Collins thanks us today. And Cliff Watson in Australia says, if it's working, keep it working. If it ain't broke, don't fix it. But interesting side note, we're going to be expecting any time in the next few months China to launch a space telescope that, though it's only about 6 feet across, they claim it'll be more powerful than the 9-foot Hubble.
Oh,
And
not
it's
know
going to
that.
be in the same orbit as their Tiangong space station. Not going to be connected to it, but they want it in the same orbit so they can easily service it.
Well, that's interesting.
Maybe pull it over, park it next to the their heavenly palace, and jump out and do a quick oil change on it.
Well, that's kind of interesting. Like I said, I never.
Yeah,
Didn't hear
that's
anything
in the
about
works
that.
there. So you were looking that up there, that boat?
I was going to check. Yeah, let me check on that because I hate to
Yeah.
have our viewers
Yeah, it's
handprints on Hubble. Kathy Sullivan.
Kathy Sullivan.
Yeah,
Okay, thank you
okay.
there. All right. And we have her handprints in our women's gallery
there you go.
in bronze. Steve, thanks a lot,
And
buddy.
thank
You
you
always bring
again.
a lot to Stay Curious, and everyone really appreciates that. Like I said, we're efforting an interview on Wednesday with a new guest that I'm not going to mention till we get them confirmed, but Terry White's confirmed for Thursday. As the coast is heating up here for this Friday,
Yeah.
6 o'clock launch. Wow, we're going to be covered all up with all kinds of tourists and visitors Friday afternoon.
looking
forward
forward to it.
that. Yep, we
Definitely.
are. Hadn't looked at the weather or anything like that,
No,
but
me
hope
neither.
everything aligns to get Sonny and Butch up in space in that Boeing spaceship. And we're wishing them well. And we'll be talking about the rest of the week here on Stay Curious. Until then, I'm Mark Marquette saying thank you for watching. Thank you for supporting our humble museum. And thank you for wanting great guests like Steve on here. Until next time, I'm Mark Marquette saying I'll see you in our museum to bridge the space between us.